J. Argolo, taking up Bachelor of Secondary Education, major in Science at Aurora State College of Technology. Today, I am going to discuss the Young double slit experiment.
In 1801, an English physicist named Thomas Young performed an experiment that strongly inferred the wave-like nature of light. Because he believed that light was composed of waves, Young reasoned that some type of interaction would occur when two light waves met. Why do we not ordinarily observe wave behavior for light, such as observed in Young's double-slit experiment? First, light must interact with something small, such as the closely spaced slits used by Young to show pronounced wave effects. Furthermore, Young first passed light from a single source, which is the sun, through a single slit to make the light somewhat coherent. By coherent, we mean waves are in phase or have a definite phase relationship. Incoherent means the waves have random phase relationship. Then, why did Young then pass the light through a double slit? The answer to this question is that two slits provide two coherent light sources that then interfere constructively or destructively. Young used sunlight where each wavelength forms its own pattern, making the effect more difficult to see. In this picture, the amplitude of waves add. In A, pure constructive interference is obtained when identical waves are in phase. In letter B, pure destructive interference occur when identical waves are exactly out of phase or shifted by half a wavelength. When light passes through a narrow slit, it is diffracted into semicircular waves. In this figure, pure constructive interference occurs where the waves are crest to crest or true to true. Pure destructive interference occurs where they are crest to true. The light must fall on a screen and be scattered into our eyes for use to see the pattern. An analogous pattern for water waves is shown in this figure. Note that region of constructive and destructive interference move out from the slit as well-defined angles to the original beam. These angles depends on wavelength and the distance between the slit. In this picture, double slits produce two coherent sources of waves that interfere. In letter A, light spreads out or diffracts from each slit because the slits are narrow. These waves overlap and interfere constructively, which is the bright lines, and destructively, which is the dark regions. We can only see this if the light falls into a screen and is scattered into our eyes. In letter B, double slit interference pattern for water waves are nearly identical to that for light. Wave action is greatest in region of constructive interference and least in regions of destructive interference. In letter C, when light that has passed through double slit falls on a screen, we see a pattern such as this. In the picture, waves follow different paths from the slit to a common point on a screen. In letter A, destructive interference occurs here because one path is a halfway wavelength longer than the other. The waves start in a phase but arrive out of space. In letter B, constructive interference occurs here because one path is a whole wavelength longer than the other. The waves start out and arrive in phase. That's all. Thank you for listening.